Okay, today we're talking about Pythagorean Theorem, but we're talking about it in the idea of distance between 2 points. So what we're going to be doing is we're going to be going on a coordinate grid, coordinate plane, such as this, okay? And we're going to be plotting 2 points on here, and we're going to find the distance between those 2 points using Pythagorean's theorem. Okay, so that's what we're going to be doing, but you got to be able to plot, so make sure that you know how to plot a point. And then 2, you got to know what Pythagorean's theorem is, which is a squared plus b squared equals c squared. So we're going to be using this, but we got to get 2 points. So the first thing we're doing, we're going to come over here, we're going to look at Get More Math, and what they say is, what is the distance between this point and this point? Round your answer to the nearest tenth. So they give us 2 points. -6, comma, -4, and -4, comma, -6. All right, so they gave us 2 points. So the first thing we're going to do is we're going to plot these points. Now there's this thing called a distance formula where you could use this, but we're not using that. We're going to be using graph paper and plotting these points and going through it like that. So you should have graph paper. Okay, so first thing we need to do is plot these points. All right. -6, comma, -4. -6. 1, 2, 3, 4, 5, 6. -4. 1, 2, 3, 4. Right there is our point. All right, then we got -4, -6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. All right. So right there is our point. Now, here's what I'm going to do. I'm going to show you the triangle so that you get to see what are we talking about and how do we work with this. So right here, this is your triangle. And then comes down across there. So what we're trying to find is the distance between here and here. Now you just can't count across and get that as an accurate number, right? You're going to have to use Pythagorean's theorem, but you don't have any numbers, so where do you get your numbers? Well, here's where you get your numbers. You count the boxes. Look, 1 box, 2 box. This is 2. Then you're going to do the same thing here. 1 box, 2 box. Now you got 2. So now I have 2 points. I have the distance from here to here and the distance from here to here. But now I'm looking for the distance here. So what do I have right here? I have a right angle. So I can take these and I put these in as A and B to find the distance of C. So that's what we're going to do. So A squared plus B squared equals C squared. I'm going to take this, I'm going to plug it in here, 2 squared plus 2 squared equals C squared. Well, 2 squared is 4 plus 4 equals C squared, and you can't really see that very well, so I'm going to switch these. Okay, 4 plus 4 is 8 equals C squared. And now you're going to take the square root of both. Square root, square root. So you have the square root of 8 equals C, and I'm going to switch over here to the calculator. Oh. My calculator went down. Hang on. There's my calculator. All right, so we were doing the square root of 8. Enter. Now remember, when it does this, you got to switch the mode of your calculator. So mode, enter, clear, second, square root of 8, enter, and you get 2.828427, but I bet you it says round to the nearest tenth. Round your answer to the nearest tenth. So 2.8, you'll look at the hundreds to decide what I do with the tenths. If it's 5 or more, you raise this up, drop those. If it's 4 or less, you leave this alone, drop those. So 2.8. 2.8. And that should do it. Yep. All right. So that's what there is. Okay, that's what that is. That's that. Okay, that's finding the distance here, your hypotenuse, by finding the distance here, plotting the 2 points, and then drawing to see what you have. I drew the actual triangle so that you could see it. You should do the same so that you can get a good count. Okay, make sure you draw that. All right, so here, same thing. What is the distance between the points shown on the coordinate plane below? Now look, here, we have the same thing. We have 2 points. Well, I'm going to do the same thing. I get to do that because I have this board here. So I'm going to come straight down, over, and now I'm looking for the distance here. Okay, well, I'm just going to count the squares. It doesn't change anything for me. I'm still, oh, forgot that didn't move. I'm still going to count the squares. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12. Now I'm going to count the squares over here. 1, 2. So this one's 2. So what am I looking for? I'm still looking for this hypotenuse. Okay, so a squared plus b squared equals c squared. Well, one of my legs is 2, one of my legs is 12. 2 squared plus 12 squared equals c squared. Okay, that's what we're doing here. Well, 2 squared is 4 plus 144 equals c squared. Add those two together, 148 equals c squared. Take the square root of both, so you get the square root of 148, square root here. Remember, taking the square root undoes the squaring of something. So square root of 148, square root, so c equals square root 148. 12.16, so 12.2. If we're rounding to the nearest tenth, yep, 12.2. So here is 12.2. All right, that's what we're looking for, and then we come down here and we plug that in here. 12.2. And that's what there is for that skill. Guys, this is not extremely difficult because all you're doing is counting these boxes and then plugging them into the Pythagorean Theorem. And we're going to do this one again. I just want to make sure you have a good understanding of what this is, because you're going to see this again, I promise you. I promise you, you're going to see this again. All right, so here, let's draw it. Come down, come over. This forms your triangle. Right here, there's your right angle. Okay? There's your right angle. So now all I gotta do is count. One box. So this side is 1. Now I'm gonna count these boxes. 1, 2, 3, 4. Notice, guys, I'm actually putting pencil to paper or pen to board or whatever you want, marker to board, whatever, so that you can actually see it. 1, 2, 3, 4. Notice I don't count this one, and notice I don't count this one. They're outside of it. I want what's in here, okay? So 1, 2, 3, 4, and 1. So, Pythagorean Theorem, I'm looking for the hypotenuse. The hypotenuse is opposite the right angle. So, 4 squared plus 1 squared equals c squared. 4 times 4, 16. 1 times 1, 1 equals c squared. 17 equals c squared. Take the square root. I'm going through it fast, but I just went through 2 of these. So this is the part that I'm worried about. I feel like we should, at this point, be able to do this. So square root of 17. Second, square root 17. 4.12. 4.1 equals c. That's what you're doing with this. Okay, so now the next part of this, 1, oh, plug plugged in the wrong number. 4.1, there we go. All right, so here, we're gonna look at the second part of this. All right. It's the same thing, look at it. Find the length of the segment. So they have this segment here, they want you to find the length. Same thing, let's just complete it. Come over, come down, count the boxes. 1, 2, 3, 4. 1, 2, 3, 4. 4 squared plus 4 squared equals c squared. That's what you're doing. Now, if you didn't have this, could you graph it? Well, they gave me the points. So if you want to graph it on graph paper, do that. They gave you the points, okay? So here, 4 squared plus 4 squared, 16 plus 16 equals c squared, 32 equals c squared, take the square root. And again, I'm going through this part fast because you should know how to do that. This part's what I'm worried about. Square root of 32. 5.7. So here should be 5.7. And I'm looking for one in particular because I know that they tell you to translate on this one. So that's what I'm looking for. We may have to go over and actually look at it here in a second. All right, so same thing. Yeah, let's go over here. Let's look at the one, because they tell you to translate this. All right, let's see if I can find one that says to translate this. Oh yeah, what is the distance between the 2 points shown? No, that's not it. It should be up here. Here it is. Okay. The point G, 3, 1, is translated 7 units to the right and 2 units up. So 7 units to the right and 2 units up. So 1, 2, 3, 4, 5, 6, 7, 1, 2. So they put a point. They put a point right here. Okay? That's the other point. And what they want you to do is find the distance between this one and the new one. Okay, so what they said is they're going to move this point to here, but they want to know the distance between those 2 points. But it's the same thing. Here's your triangle. Okay, there's your triangle. Count it. 1, 2, 3, 4, 5, 6, 7. So you have 7, and then you got 1, 2. 2. So 7 squared plus 2 squared equals c squared. That was the other problem I want to make sure that you saw. Okay, 7 squared, 49 plus 4 equals c squared. Then you got 53 equals c squared. All I'm doing is I did the 7 squared and 2 squared, then I added those two together, take the square root of both sides, and now you're off and running. All right? Be careful with this one. Make sure that when you translate it, you translate it at a good point. Be very, very careful with that. Okay? Because it's really easy to do. Really easy to make a mistake. All right? That's it for this. I mean, that's how you do the distance on a graph. You gotta have, I would have graph paper when I try to do these. Would not try to do this without it. I'd be very careful when I did do my graphing, because if you plot the point incorrectly, you're gonna get a bad answer. So pay attention. Remember, when they give you the points, they're really giving you both the legs, is what they're doing. Okay? You're going to be looking for the hypotenuse, unless they do something weird on these. So pay attention, be aware of what's going on. If you need help, let me know.